So, hi, so my name's Steve. This is a basic introduction to Go Unicode. So it's not complicated, I'm trying to keep it fairly simple. It's the basics of what most programmers, I think, probably need to know how to handle those funny characters. So why do we need Unicode? Well, there's over 6,000 languages in the world, and many of those don't use ASCII, they use non-Latin characters. So US ASCII is 7-bit. That's a sort of classic computer terminal character set, so that's 127 characters. It doesn't include either the euro or the pound symbol. So for the euro and pound symbol, Latin 1 and Latin 9 were developed, which are 8-bit characters. But nowadays, if you're handling those 6,000 languages and you want to send funny animated emojis on your phone, what you need is Unicode, which has over a million possible characters. And it's standard for web pages and email. And the last standard, so basically Unicode 10 dates from last year.
Is that UTF-8 or UTF-16?
You're just talking about Unicode. That the UTF-8 is the encoding of Unicode. I'll kind of come to that. So I'm going to sort of define the parts here of Unicode. So at the top of the stack we have graphemes, which are roughly human language characters. So originally you just used to have characters and bytes, which were interchangeable, but now you have code points, which are 32-bit integers, which are things that the Unicode spec gives numbers to. Those are also called runes in Go. And of course, right at the bottom of the stack, actually on the disk and in memory, you have bytes. So everything really is just bytes at the bottom, code points, and then graphemes at the top. So the whole talk is really about how the stack plays together. So there's some examples here of how you can use Unicode in Go. So you can type it directly on the terminal if you know the magic the magic keystrokes. So you've got 3/8 there, which is called vulgar fractions, 3/8. So if I run those, then you can see what the bytes look like and what the code points look like. So so you can see that the code point and the bytes are different. In fact, that's 3 bytes, and I think that's a 32-bit code point. So essentially I've been talking about Unicode, but there's encoding. So that's exactly how Unicode is represented in bytes. The simplest way of doing this would be to use fixed length encoding. So I said it was 32-bit ints. So if you used UTF-32, it would be very simple. You just have fixed length encoding. However, that's very wasteful because most of the common characters, you don't need 32 bits. Also, UTF-8 was developed, which essentially is a superset of the existing ASCII, so it's compatible with it. There's also one here I quite like, which is WTF-8, which is a wobbly transformation format, which is probably something very bad, as you can tell from the name. Don't use it. It's a Mozilla hack that's used to fix problems internally with encoding, and Mozilla say don't use it. I thought the name was amusing. So emoji bait. When people first started using these exotic encodings, everyone saw a lot of scrambled, jumbled up, unreadable characters on web pages. It tended to be a Japanese or a Windows problem. Japanese has a large number of encodings, and there was problems between moving them, and the Windows encoding, the code page one, has been problematic in the past. But nowadays, everyone should just really stick to UTF-8. And of course, there's a classic problem here with the iPhone was crashed by, you could just send one Indian character to it and it would completely crash the iPhone. So there's even problems now. Note this isn't, that Emoji Bake is specifically a problem to do with encoding. So that if you go to a web page and the characters aren't visible, that's not necessarily Emoji Bake. That could simply be that the font that's being used in your web browser, it doesn't have that character and can't display it. Emoji Bake, if you see it, it's something, it looks like line noise, it's scrambled up. It's quite obvious. So yeah, UTF-8. So a code point which is 1 byte ASCII, that can be 1 to 4 bytes. So it's variable length. And the way that you determine what the length is to look at the high order bits of the first byte. So the first line here I've got is just completely compatible with standard ASCII, and you have the high bit of the first byte is set to 0. And the second one, 110, is the high bits of the second byte. So that gives you more characters for a 2 byte encoding. I haven't put the 3 and 4 byte encodings on, but basically there's a table that you can find online, and it progresses in much the same way. So there's 2 sorts of code points. There are 16-bit code points. In Go, we use a lowercase u in the string literal. So here you can see that there's a slash and a u, which is the 16-bit code point. So I'll run this just to get. So that's a pound sign. So the length in bytes is 2 bytes long, and length in runes is 1. One of the things about these encodings is that the idea of how long something is very variable. It depends on which level of the stack you're looking at, and it gets quite confusing. So I'm going to give plenty of examples of showing which, what I'm looking at, whether I'm looking at bytes or runes. So a 32-bit one here, you can see is longer, and it has a capital U. And if I run that, that's a euro symbol, so that's actually 3 bytes long, and that's still one rune. So the previous one was 2 bytes, this is 3 bytes. There's another one which I quite like. There's a lot of quite amusing characters to be found in the Unicode character set if your font supports it. So if I run that, it's a cat laughing with tears of laughter, that's 4 bytes long, and again it is 1 rune. In fact, because I'm running this on a Mac, you can see it in colour, but if I was to be running it on Linux, it's quite difficult to get the colour emojis on Linux. There are a couple of ways of doing it, but I've had problems with it, and really the Mac is probably the easiest way of displaying this stuff currently. Okay, so the next example, I've got an accent on its own, which is an acute accent here. So you can see that's 3 bytes long, but it's 2 runes. So yeah, it's not you're not necessarily got 1 rune. You can have 2 runes for a grapheme on the screen or a character. Also, this accented E is interesting because there's another way of displaying it. So this is just essentially 2 runes, but you can combine you can combine the E itself with the accent separately, and I'll come to that. So that's a composite Unicode character. And one of the things that this is used for is skin tones. So originally the emojis were of one colour, but you can add colours to the emojis now. And in fact, one of the things that I was experimenting with was trying to get this to work by combining other characters, but not many of the fonts use this. And that Guinness, in fact, have a Twitter tag here, Stout emoji. So essentially what it would be nice to do is to get a pint of lager and add a browner or darker colour to it to get a pint of stout, like a dark beer. However, this isn't supported yet, but there is a campaign. So if you all tweet Stouts emoji, then maybe the Unicode Commission will come out and actually produce, ales and stouts rather than just lagers. Okay, this is a rather contrived example, so I'll run this. So I've got a very strange character here, which is a D that has 2 dots on it. So this is 5 bytes, 3 runes, but 1 grapheme. So if you look at it, it just looks like 1 character. But it isn't really 1 character. It depends on how you look at it. If you look at it as runes, it's 3 runes, or bytes, it's 5 bytes. So and also getting the actual length in graphemes, which is what a human would think a character is not trivial. Previously, I was just using len to get the length of it, and then casting it to rune or looking at it directly. Whereas this, you actually have to do some logic here, and I'll come to what some of this means. Okay, normalization. So previously, when I showed the accented E, I was creating that by this form here, 2, which is just to use one Unicode character. However, by composing 2, so that's a normal E, and this is saying add an accent to it. But the problem is, because we've created the same thing in 2 different ways, that you can't compare them by simply using equality, because the 2 things are different, but they look the same on the screen to a human. So what you have to do in order to get the comparison to work is to normalize them. So if I just run that. So you can see that the first one has these bytes, and the second one, the 2 of them, if I print them out at this point, they look identical on the screen. However, if I do the equality, the 2 aren't equal. However, if I normalize them, I can then do the comparison. So if you're ever trying to compare equality of this sort of thing, you need to normalize before doing it. Yeah, that's it really. Just a quick plug for Suffolk Gophers here. So Suffolk Gophers doesn't have a huge number of people, so 2/3 of them are here. There is someone else, Elliot, but but yeah, the slides are available there, and I think Sue's slides will be. And has anyone any questions?
Just a quick one. The accent, is that a character on its own as well? In the previous slide, the U30.
Yes, it's basically represented there as, so that's a 16-bit Unicode character, 00E.
And that can stand on its own. It doesn't have to be. You can print it out just on its own as well.
Yes, in fact, I mean, I should be able to. Can I modify it? I forget. No, I can't. No. Well, if I probably should have had a link to the Google, to the Go Playground to do that. But yes, that's. In fact, the other thing I should have said too is that people tend to still say things like characters, and one of the problems with this is that no one, even though there are different things like graphemes, runes, and code points, that in common use people use the wrong terminology, and you just. I mean, I've been trying to sort of say the right terminology, but it slips out, and you call things characters, and they're not really characters.
Java's UTF-16. You didn't mention UTF-16. Is that my memory fooling me?
I think you're right, but I'm not a Java expert, and I've not looked at it.
Yeah, but you didn't mention UTF-16.
I think there's a huge number of different UTF encodings, so yeah, maybe I should have mentioned UTF-16, but I think there's several. I mean, to be honest, sometimes I think things would have been simpler if they just used UTF-32, but I know it would have been inefficient because you'd have had 4 times as many bytes for simple things, but it's just easier to get your head around.
Would that make sense for a language like Japanese, where they always have to use UTF-16 basically, or UTF-32?
I think the Japanese are odd because they essentially started off with their own encodings. I think they now use UTF-8. I think everyone basically uses UTF-8, and there's not, apart from, as you said, UTF-16, I don't think there's much use of anything else.
So is graphemes a phrase that is only applicable in Golang, or is it just a word that everybody should use instead of character when they're referring to a thing on the screen?
I think it's more the latter. In fact, the other thing that I didn't say, which I probably should have said, it may have been on one of the slides, is that UTF-8 is particularly closely associated with Go because the creators of Go also created UTF-8. So that people use other the terminology is always very muddy. It's very confusing, and that people frequently say the wrong thing.
So they made Go and UTF-8, but they didn't make a way of counting graphemes easily. You had to write your own little.
You have to do it. Oops, sorry. It's not. I mean, it's not that complicated. I mean, if you're going to do it frequently, you just have a little function doing it. But
Because that's what I thought the length.
no,
was
the
doing.
no, the length.
Because I only heard of the characters before.
Length usually works, but as I tried to show here,
Yeah.
that with this odd made-up character that just happened to show my point that no one uses. In fact, if anyone's got a better example, tell me. I'm sure there's one that's clearly one character, but you have to do this. And as far as I know, there's no way that you can do it any other way than this, which is to explicitly go loop through. Any other questions?
Well, there's one language that I know of that gives you the right answer with length.
Was that Pearl 6?
Pearl 6. because the guy that implemented it went into a lot of trouble to have whenever you do length on a Unicode string, it does the right thing. You know?
That's why it's so late, right?
Yeah, that's
Just
not, no,
reason.
that's just one of the many things that they
Yeah.
it's late because they couldn't decide what they were going to do.
Yeah, that's kidding.
Okay, I'll push the button on this.
Okay, thank you very much.
So I've got the clapping on the video actually.
Yeah.